So in an ice age and during a hot age, ice age would need a pressure suit, and in a hot age you would need a depressurization suit, if there is even such a thing, or a decompression chamber. And I wonder if the more we age in our lifetime, that we should be in more hotter climates in a depressurization chamber. And naturally, this should knock off the effects of heat, which then allows cooling. And under pressure, it should be easier to heat. Interesting. Interesting. Because we look at the black hole, so to speak. Black hole would be more like an ice age, wouldn't it? And a star more like a hot age. So if you were to depressurize, would the gases become colder? Would this allow you to travel through a star and to go through I don't know, a black hole, which would mimic an ice age? Would you need pressure? And therefore you can pressure cook, as opposed to depressurization is harder to cook. It seems to be. Yeah, I don't know if these are shades of grey, but even still, either or. It's not only the heat that gets you, it's also the pressure. Not sure if that's how you spell it, but I don't really care. Heat and pressure, that's what's building. So to lower the heat is to lower the pressure. Which could make cooling cheaper. Yeah, very interesting. Because in space, there isn't much heat, is there? And that is depressurized, therefore minus 350, not the black hole. Below zero, minus zero, around that, isn't it? I think it is. And the closer to the star you get, well, the skin of the star is going to be a certain heat. This next layer is going to be a certain heat. Next layer, next layer, next layer. It's going to increase in temperature the more closer to the core you get. And I say closer, and the same would be said for a black hole. The further in you get, the more intense the pressure becomes, or the the depressurization becomes. So the lack of pressure, even more so lack of pressure, and therefore I think that it's cooling down each layer. So this will be cold, space being zero. Minus one, we'll have to say then. Yeah, let's just say minus one. It's permanent marker, so I can't rub this one out, but the others are, I think in the heat, they seem to disappear quite a bit. So the further in you go, so space, cold, 350 degrees, and then perhaps the next one into a black hole, its skin is even colder. The next layer is probably times two that.